Welcome, focused learners. Imagine for a second that you're stepping into a boxing ring. The overhead lights are absolutely blinding, the crowd is roaring in your ears, and right across from you isn't some heavyweight champion. No, it's a Cambridge computer science past paper. The clock is ticking down, that tension-building music is playing in the back of your mind, and you are staring down a fiercely complex question on hexadecimal applications. Today, we are completely transforming how you handle this. We're taking hexadecimal representation from being just a memorized, isolated fact and turning it into a high-scoring, practical, undeniable exam strategy. Think of this explainer as your ultimate training camp for the Cambridge exam. Your new mantra? Float like a concept and sting like evidence. Jab, cross, hook, these are your answer combinations, and we're going to perfect them. To really illustrate this, I want to introduce you to two specific students, and trust me, examiners see these exact two students in exam halls every single year across syllabus codes 0417, 0478, 2210, and 9618. First up, we have Alex. Now, Alex is the classic overloader. Alex jams every single answer with raw, unfiltered computer science facts. If a question even breathes the word hexadecimal, Alex writes a literal novel on converting binary to hex but completely ignores the actual context of the question. No analysis, just a massive data dump. Right next to Alex is Sam. Sam is the rusher. Sam sees a tricky topic, immediately panics, writes down a one-sentence, incredibly generic response, and completely misses the command word requirements. When we look at both of their past papers side by side, it is just a tragic sea of red pen marks. 0 marks for context, 0 marks for application. All that hard work, totally wasted. Well, today, we are going to fix that forever.
Okay, let's dive into our 6-step roadmap for mastering this. We'll start with why context is everything. Learn how to distinguish those tricky nearby concepts and build a foolproof 4-prompt memory structure. Then, we'll tackle exact exam methodology, systematically eliminate common errors, and finish strong with a 3-pass revision cycle.
Section 1. Context is everything. Let's get right into it.
To really understand why context is everything, let's look back at our two students, Alex and Sam. When they were faced with a question about hexadecimal applications in a school network, Alex just mathematically defined base 16. Sam literally just wrote, "It takes up less space," which is a classic, completely incorrect response that examiners eagerly penalize every single time. As a Cambridge student, you are expected to use precise terminology, explain the underlying processes clearly, and crucially connect your explanation right back to the specific scenario they gave you. So, before we look at a single line of code or data, I want to challenge you directly. Ask yourself right now, what digital problem does hexadecimal actually solve? We have to establish an application-first mindset. To do this, we need to decode the command words used by examiners and apply a system that top students swear by. It's called the PEAL framework. That stands for point, evidence, explanation, and link. When a Cambridge command word asks you to explain or justify the use of hexadecimal, you have a sequence to follow. You make your point, you provide your specific technical evidence, you give a crystal clear explanation of the process, and then you link it right back to the scenario. And hey, before we continue, subscribe to our YouTube channel Ace the Exams, at @acetheexams_IGCSE to excel in your Cambridge examinations. Click that subscribe button and hit the bell icon right now. Okay, let's get back to the framework.
Let's step back into the ring and apply that PEAL framework. Your terminology only becomes meaningful when we physically connect it to real-world devices and systems. The source material is very explicit about this. A strong learner first clarifies the purpose. What data or device is actually involved here? What digital process is taking place behind the scenes? What is the practical consequence for a user, a system, or a global organization? When you anchor the concept of hexadecimal to MAC addresses inside smartphones or HTML color codes in website design, memory dumps in school grading systems, or error codes in automated robotics and industrial networks, the terminology magically stops being a random string of characters. It becomes a living, breathing tool. You start to see that hexadecimal solves the incredibly frustrating problem of human readability. It makes massive, unwieldy strings of binary significantly easier for human programmers and technicians to read, write, and debug without making typos. If you just memorize base 16, you fail. If you explain exactly how a network technician uses it to debug a robotics network faster because the error codes are shorter on the screen, you win. That is how you turn those red pen marks into green check marks. Float like a concept, sting like evidence.
Section 2. Distinguishing nearby concepts. Absolute clarity between similar ideas is the bedrock of high marks. Examiners absolutely love to test the boundaries of your knowledge by placing two really similar concepts right next to each other and asking you to compare them. Notice how examiners constantly catch students confusing memory versus storage. They mix up protocol and service. They swap compiler and interpreter. They blend social engineering and malware. It's a trap. Imagine Alex and Sam tackling a question comparing memory and storage in the context of an embedded system. Alex writes an entire page on RAM, completely forgetting the embedded context. Sam writes that storage is just, quote, bigger memory. Both get heavily penalized. But watch this transformation when we apply our strategy and the Peel framework. We clearly define memory as a temporary, volatile workspace for immediate processing, and storage as a persistent, non-volatile retention of data. We explicitly explain the difference in access speeds, and we link it directly back to the specific embedded system scenario provided in the paper. That is how you turn a generic answer into a highly specific, examiner-rewarded performance. And listen, stop scrolling. Subscribe to our YouTube channel, Ace the Exams, at acetheexams_IGCS to excel in your Cambridge examinations. We've helped thousands of students improve by 2 to 3 grade boundaries. Join them right now by subscribing to at acetheexams_IGCS and turn on all notifications so you never miss our weekly exam strategy sessions.
Section 3. The 4-prompt memory structure. To make absolute sure you never mix those concepts up under the immense pressure of the exam room, you need a reliable, repeatable rhythm. If you can look at literally any computer science topic and confidently answer these 4 distinct questions aloud, the topic is ready for the exam. Prompt 1. What is it? Define hexadecimal precisely. Prompt 2. How does it work? Explain the underlying process, the grouping of binary bits into 4s, the characters 0 to 9 and A to F. Prompt 3. Where is it used? Name the exact real-world scenario, HTML color codes, IPv6 addresses. Prompt 4. Why is it better or worse than an alternative in that specific situation? Explain that it is significantly shorter for humans to read, making it way easier to spot errors compared to staring at raw binary. But remember, and this is crucial, always note that the computer itself still processes it as binary. This 4-prompt structure is your ultimate training regimen. It physically forces you to map directly onto the point, evidence, explanation, link framework every single time you study.
Section 4. Exam Methodology. Let's talk execution. Okay, you've done the training, you know the theory inside and out. Now, how do we actually execute this on a real, terrifying examination paper? I want you to read this stark, uncompromising warning directly from the examiner reports. Generic responses rarely gain full marks. Let that sink in. Context is absolutely mandatory for scoring well. If the context of the question is a school network, an office building, a tiny embedded system in a washing machine, or a massive cybersecurity incident, your answer must stubbornly stay inside that context. Students so often know the theory flawlessly, but they bleed marks simply because they fail to anchor their explanation to the specific details provided on the page. To guarantee you stay in context, you must strictly follow this technical methodology. It's time for an interactive workshop. Step 1. Identify the exact requirement of the task. What is the command word asking? Is it asking you to state, describe, explain, or evaluate? Step 2. Classify the relevant data, hardware, or process involved. Step 3. Explain the sequence clearly. Imagine you are explaining how the process works to another learner who has literally never seen it before. Do not skip steps. Step 4. Connect it back to the context. Check whether the question wants causes, effects, advantages, or evaluation, and fiercely tailor your final sentence to match. Let's test this right now with a data scan challenge. I'm putting 60 seconds on the clock in our minds. Look at the data table on your screen. It's a memory dump from a retail cash register system. If you scan this massive wall of data quickly, what is the core trend? Time's ticking. The core trend isn't just that it's a bunch of random numbers and letters. It's that the system specifically uses hexadecimal to represent specific error logs from the cash registers. This makes it infinitely faster for the IT team to diagnose hardware failures without having to manually parse endless, dizzying rows of zeros and ones.
Section 5. Avoiding common errors.
Good notes and great students don't just learn the correct pathway. They obsessively study the classic mistakes so they never, ever make them in the ring. Look closely at this comparison. In column 1, we have the classic wrong turns, vague wording, generic application, naming a device without explaining how it works. In column 2, we have the examiner-style performance, hyper-context-specific answers, every single step of the sequence explained, and crystal-clear reasons given for every advantage. Let's do a Find the Flaw challenge. I'm going to give you a deeply flawed sample paragraph. Listen closely. Hexadecimal is used in MAC addresses. It is better because computers process it faster and it takes up less memory on the hard drive. All right, spot the flaw. Why does this completely tank your score? First off, computers absolutely do not process hexadecimal faster, they process binary. Hexadecimal is purely for human convenience. Second, hexadecimal does not magically take up less memory. The underlying binary data size remains exactly the same on the disk. The only thing it takes up less of is actual screen space for the human reading it. Now for our speed writing challenge. You have 30 seconds to rewrite that flaw into a perfect peel paragraph. Go. All right, time's up. You should be writing something exactly like this. Hexadecimal is used to represent MAC addresses to make them shorter and easier for technicians to read. That's your point. A 48-bit binary MAC address is displayed as 12 hexadecimal characters. That's your evidence. This reduces the physical length of the address on the screen, making it significantly easier for human administrators to configure network hardware. That's your explanation, thereby minimizing data entry errors when setting up the school's new router. And that is your link. Perfect. 100% mark potential. To recap those fatal pitfalls, lock these into your memory right now and eliminate these behaviors from your practice immediately. Vague wording, confusing similar terms, missing process steps. Listen, don't jump from A to C, you must explicitly explain B. Failing to answer in the context of the question, and naming a device or a method without explaining how it actually works or giving an advantage with absolutely no underlying reason. Cut these out, and your grade boundary jumps up effortlessly.
Section 6. The 3-pass revision cycle. We have covered the dense theory, the common errors, and the exact exam methodology. Now we arrive at the final system, the cheat sheet recap. To deeply ingrain these 3 rules for top marks, command word decoding, Peel framework application, and your time management matrix, you need a disciplined revision strategy. A truly strong revision cycle should include exactly 3 passes. Pass 1. Secure those key definitions and contrasts. Make absolutely sure you can define hexadecimal and contrast it flawlessly with binary and denary. Pass 2. Rehearse worked explanations. Don't just read them, physically write them out. Practice the Peel framework until it's pure muscle memory. Pass 3. This is where true applied reasoning and top grades are achieved. Focus heavily on exam adaptability by deliberately changing the scenario. If a past paper asks about hexadecimal in a banking system, challenge yourself to answer how it applies to an automated factory robot or a massive media processing server. Because questions in Cambridge exams often combine theory with applied reasoning, this 3rd pass is your ultimate preparation.
So, I leave you with this one final, absolutely crucial thought as you look ahead to your next study session. Are you going to be like Alex and Sam, just throwing wild, generic punches in the dark and hoping you score a point? Or are you ready to step into the ring with a proven strategy and rebuild your very next complex topic using the 4-prompt memory structure? The choice and the championship grade is entirely up to you. And remember, students who implement these computer science strategies see an average improvement of 2 grade boundaries, but only if they practice consistently with our weekly videos. Here's your final reminder. Subscribe to our YouTube channel Ace the Exams at @acetheexams_IGCS to excel in your Cambridge examinations. Subscribe right now to @acetheexams_IGCS and click that bell. Don't let another exam pass you by. Drop a comment below with your target grade for computer science and the biggest challenge you're facing. Our team responds to every comment. Like and share this video with a study partner. Ace the Exams, your Cambridge success starts here. Keep learning, keep pushing, and I'll see you in the next explainer.